Hi everyone, welcome back for part 2 of this week's session looking at mediation and indirect effects. So we left off with some coverage of the traditional or relatively old-fashioned approach to testing mediation and indirect effects using the technique suggested by Barron and Kenny. So one of the reasons that we now have more up-to-date techniques for testing mediation and indirect effects, that's sort of grown out of a couple of important critiques of that Barron and Kenny approach, that so-called Barron and Kenny approach. So I'm going to cover those. So one is that it's no longer seen as strictly necessary for the C path, that initial path between the predictor, let's say attitudes to healthy eating, and our outcome variable, healthy eating behavior. It's no longer viewed as necessary for that to be significant to proceed to test indirect effects. Now, the reason for that is there are reasons why you may not see a direct association between a predictor and an outcome variable. The relationship might be quite distal, for example. The measures might be separated by quite a long time period, for instance. They might be temporally distal, but they might also be conceptually distal as well. There might be quite a few mediators in turn that link the predictor to the outcome variable. So an example in practice here is one that comes from research by Gordon Harold and colleagues. Now, they were interested in whether conflict between parents affects a child's adjustment, specifically their levels of distress, 1 year later. So what they found is the direct association between parental conflict and children's distress a year later was almost zero. It wasn't significant. But parental conflict did predict children's perceptions of parental conflict. And those perceptions of parental conflict in turn predicted children's perceptions that their parents are hostile in general. And that in turn does significantly predict children's distress. Okay, so the link here is, I guess, zero in basic terms, but indirectly there are multiple steps and it's also temporally distal. There is evidence of an indirect association. So a second critique that's highly relevant is that there are more robust alternatives to the Sobel test for testing the significance of an indirect effect. And those more robust alternatives are based on bootstrapping and confidence intervals. Now, the critique of the Sobel test here is specifically that it's vulnerable to bias resulting from, on the one hand, violated parametric assumptions, but also small sample sizes. So those violated assumptions, we can start to get around them by using bootstrapping, which is a more non-parametric way that doesn't have as many distributional assumptions of generating a standard error and in turn inferential statistics. So bootstrapping, what is it? What it involves is taking an original data set, let's say data from 10 participants. And bootstrapping involves generating thousands of new samples based on sampling with replacement from those original 10 participants. That's whatever your original sample is. So it'll create a second sample by randomly selecting 10 values from that original 10, with the proviso that with replacement, that means that you could select the same participant 2 or 3 or perhaps even more times just at random. Okay. So what that means is you're generating thousands of new samples that are based around your original sample, but could be slightly more extreme on the negative direction, slightly more extreme in the positive direction, or simply align with the original. Okay. Now what that does is provides a non-parametric basis for estimating how variable a sample estimate is, for example, the mean or an effect, and also for constructing confidence intervals for the effect. So confidence intervals. Now we covered that very briefly, or I mentioned them in the context of the analysis of variance lecture, for instance. So what actually is a confidence interval? Well, a confidence interval is an estimate. It indicates the potential range of an estimate. Now that estimate can be, I guess, well, there are all sorts of estimates that we might be interested in. A mean value for a sample, for example, or in our case, a mediation coefficient, the coefficient of an indirect path between two variables. Now, the range of a confidence interval is determined by our preferred confidence level. Now, the default is a 95% confidence interval, which, as we'll see, is similar in logic to the default p-value threshold, the alpha value of 0.05, and we'll see why. So when we see a 95 or use 95% confidence intervals, there's no strict reason why it has to be 95%. It's a convention. But in the end, ultimately, you can choose the confidence level that you like, a 99% confidence interval, a 90% confidence interval. So a confidence interval, because it contains a range of values, has an upper and lower limit with specific values that are estimated from the data. So what does a 95% confidence interval actually mean? Okay, so the technical version is that if we ran the study using exactly the same method, in the long run, maybe we ran it 100 times or 1,000 or thousands of times, we would expect the true population effect for that method, the real population effect, to fall within those upper and lower limits, to fall within our confidence interval 95% of the time, in 95% of those tests. So, what that means in terms of making inferences about whether a test is significant or not is that if the value of 0 falls outside of the confidence interval, okay, and we're assuming that our test is one of the 95% that in the long run would include the true effect, then what we're saying is that the true effect is different from 0, okay? So on the one hand, if our test is one of the 95% that contains the true value of the estimate, okay, the true value of the indirect effect in our case, and also that 0 is not within that interval, okay, but the true effect is, then we're saying that the true effect is not 0. That's the logic. In other words, it is significant. So you see here why a 95% confidence interval is often seen as mapping, at least in terms of logic, to an alpha threshold of 0.05. What you're leaving yourself with is the 5% chance of misinferring the result. Okay, so an alpha threshold of 0.05, an alpha value of 0.05, or p threshold, means that, again, in 5% of long-run cases, okay, you have made an error in your inferences. And that's similar in logic to the 5% of times in which our test of the hypothesis of the indirect effect is not one that includes the true effect. So let's try and make that a little bit more concrete in terms of interpreting what a confidence interval shows us. So our confidence interval, for instance, in this case, the confidence interval for an indirect effect, a mediated effect, based on our bootstrapping, let's say we end up with a distribution of indirect effects from our 5,000 bootstrapped samples. Our confidence interval for those have upper and lower limits. That's the lower limit and that's the upper limit. And the 95% confidence interval suggests that, again, if we ran this thousands of times, we would expect the true effect to fall within this interval 95% of the time, in 95% of those tests. So in terms of making an inference then from a bootstrapped mediation analysis, what we end up with is a confidence interval for the indirect effect. Okay, and here's a range of possible values. A value of 0, which non-significant, there is no mediated effect, a positive mediated effect, and a negative mediated effect. Okay, and these are possible values for the coefficient. Here's a confidence interval that in this case contains 0. Okay, so if the lower limit and the upper limit, the values between those, that range, contains 0, then we would regard the effect, the mediated effect, the indirect effect, as non-significant. If, however, our confidence interval looked like that, okay, that's the lower limit and that's the upper limit, that interval, that confidence interval does not contain 0, 0 is over here, then we would regard the indirect effect as significant. So again, some examples when it comes to actually reading off a set of confidence interval upper and lower limits. Okay, so let's say the analysis provides confidence interval lower and upper limits as follows. Would in each case these be regarded as significant or not? So this first one, the lower limit is 0.025. The upper limit is 0.3486. Okay, would we regard that as significant? Yes, because the value of 0 falls outside that interval. It's lower than the lower limit. What about this case here? So we've got a lower limit of minus 0.46 and an upper limit of 0.16. Well, no, we wouldn't regard that as significant because 0 falls between those two values. This third example here, we would regard this as significant because our lower limit, minus 0.53, and our upper limit, minus 0.03, does not contain 0. 0 falls above the upper limit. In this final example, a lower limit of minus 0.01 and an upper limit of 0.45. No, we wouldn't regard that as significant because again, 0 falls between those two values. Okay, so that's how we make inferences from the confidence intervals constructed using the bootstrapping approach. In terms of how to do that in practice, in Jamovi, we use the jAMM module, the General Linear Modeling Mediation module in Jamovi. So that's something that you need to add. If you haven't done so and you're running through these examples, best to add it first. That's the module that we'll be using. So I'm going to go back to Jamovi and run the analysis or test that mediation model that we tested first of all in the first part of this session using the Barron and Kenny approach. This time I'm going to go to this drop down, MedMod, where we find the jAMM module, GLM mediation model. Okay. And here's the interface. So what I'm going to do is, click on that. What I'm going to do, first of all, specify our outcome variable, which is behavior. We have attitude, which is our predictor variable. That's entered as a covariate, a continuous predictor. And we've got intentions as our mediator. Okay, that goes in the mediators box. So we can see here that it's providing a path diagram that helpfully summarizes what you've specified for you. And that sort of confirms that is indeed what we want to test. If we scroll down, we will see already an output table which contains basically all you need from a mediation analysis from a Barron and Kenny perspective. We've got our component paths, the path from attitude to intention, that's the A path, from intention to behavior, that's the B path, and the C path from attitude to behavior, the so-called direct path from attitude to behavior. Okay, and as we saw from the first analysis, the A path, significant, the B path, significant too, and the C path, not significant. All right, and we also have a test of the indirect effect from attitude to intention to behavior. There's the estimate, the standard error, and the Z-score. Okay, now what we need to do is ask for the bootstrapped version of that test of the indirect effect. So what I'm going to do here is under the mediation options drop down, I'm going to ask for it to do, rather than the standard method, I'm going to ask for it to do 5,000 bootstrap resamples, okay, with a 95% confidence interval, that's the default, and for bias corrected BC bootstrapping. Okay. And now it's going to update the analysis using that slightly different method of estimating the significance or testing the significance of the indirect effect. Now, one thing to say about this is it's a bit more computationally demanding than the previous method because it's effectively running the test thousands of times. That's what the bootstrapping involves. So you'll see here it's having a good long old think about it. Now, just to save us time here, I'm going to go back to one that I've run already. Okay, so this is the output you would get. Again, there's our model, attitude to intention to behavior. And here are the outcome here's the output table. Okay, our A path, our B path, and now our indirect path estimated using bias corrected bootstrapping. Okay, so let's just nip back to the presentation to make sense of that. So here's that output table. What can we see? Well, first of all, here's our A path, the effect of attitudes predicting intentions, highly significant. Here's our B path from intentions, the mediator, to behavior, highly significant. And here's our C path, controlling for the mediator, not significant. And in turn, we have the coefficient for the indirect effect, 0.66, the lower and upper limits of the bootstrapped confidence interval, and we can see that 0 falls outside these limits. The lower limit, 0.39, the upper limit, 0.99. So we would regard that effect as significant. And again, we can help to communicate the results of a mediation model, an analysis, by using the path diagram and adding in the coefficients and their significance. Here we've got a positive predictive association between attitudes and intentions, likewise intentions and behavior, and our indirect effect is reported as follows. We've got our coefficient, our bootstrap standard error, and the 95% confidence interval limits, 0.39 and 0.99. I should stress here that technically the thing that's being bootstrapped in these analyses is the standard error. Okay, so because the standard error is in turn used in the construction of the confidence intervals, that's why we refer to them as bootstrapped confidence intervals, because they use a bootstrapped standard error. So that's the thing that's being bootstrapped. All right, and again, with slightly cautious causal language here, the findings are consistent with the hypothesis. Note that they don't show that mediation happened. They are consistent with the hypothesis that intentions mediate the effect of attitudes on behavior. Okay. Now, it's also possible to test the role of two or more mediators simultaneously. So remember, one of the things I wanted to do in each of these sessions is show you how your analysis options change as your model and what you want to do analysis-wise becomes more complex. So what we've done so far is test a simple mediation model with one predictor, one mediator, and one outcome variable. Okay. It's also possible to test models in which you have two or more mediators simultaneously. So let's say our researcher are interested in what predicts healthy eating behavior and through what processes. They might reason that, well, attitudes to healthy eating might predict behavior not just because of their individual level intentions, but it might also make people aware or more attuned to healthy eating opportunities. For example, in cafes or when they're out buying food, for example. It might orient them more towards healthy options amongst a set of other options that are perhaps less healthy. All right. And that in turn independently helps to explain the link between attitudes and behavior. So now attitudes to behavior is linked through two indirect paths, one via intentions and one via opportunities. So what this will involve is testing these indirect effects. So for example, the indirect effect via intentions, while adjusting for or controlling for any separate effect involving opportunities or awareness of opportunities, and vice versa. Okay. So let's see that in action. Let's go back to our original example. It's still working through that first example. So let's start from scratch. Let's go to the jAMM module again. And now we're going to specify a model in which we have behavior, again, as the outcome variable, attitude as our predictor, as a covariate, because it's continuous. We have intention as a mediator, but now also we are entering awareness of opportunities as a second mediator. And that path diagram now summarizes the model. So we're just checking here that we've specified it as we intend. So we've got attitude predicting behavior, so it's got a direct link, but it's also got these two indirect paths via intention and opportunities. Okay. There's the default output. Okay, and now I'm just going to ask it to do the bootstrap tests of those indirect effects. Okay, 5,000 bias corrected bootstrap samples. And again, it will take a while. So I'm just going to skip back to a version that I've already run of that model. There we go, with the 2 indirect paths. And here is the bootstrap version of that analysis. So we've got our component paths here. Now we've got 2 A paths and 2 B paths. So we've got the A paths from attitude to intention, significant, and from attitude to awareness of opportunities, also significant. And we've got 2 B paths from the mediator intentions to behavior, significant, and from the mediator opportunities or awareness of opportunities to behavior as the outcome, which was not significant. And now we also have tests of 2 indirect effects, okay, indirect paths. One from attitude to behavior via intentions and one from attitude to behavior via awareness of opportunities. And we can see that that indirect path via intentions over the top of the diagram is significant, but the indirect path via opportunities, the bottom root in that diagram, is not significant. Okay, our confidence interval here, lower limit minus 0.097 and plus 0.284. That does contain 0, so it is non-significant. Okay, so again, just to reiterate there, summarizing this model, we can say that the indirect path from attitudes to behavior via intentions was significant, but the indirect path from attitudes via opportunity awareness to behavior was not significant. And there's how to write up the estimate, standard error, and upper and lower limits of the confidence intervals for the 2 indirect paths. So let's extend it further. Okay, let's say we have a model or a set of a predictive model that involves more than one predictor variable as well, because more than one thing could potentially be affecting healthy eating behavior. So in addition to attitudes, our own attitudes to healthy eating, another thing that might shape our behavior are our perceptions of the norms of the people around us. Okay, what are other people? What do other people both approve of in terms of healthy or unhealthy eating, and also what do they typically do? Okay, so this gets at sort of more, in addition to our attitudes, it gets at the extent to which we are socially influenced when it comes to healthy eating behavior. So the model the researcher wants to test here involves looking at 2 predictors and whether they predict healthy eating behavior indirectly in turn via 2 mediators. So when we have 2 mediators and 2 predictors, we have 4 potential indirect paths. From attitudes to behavior via intentions and opportunity awareness, and from the perceived norms to behavior via, again, intentions and awareness of opportunities. So what this model will involve is testing whether these 2 predictors predict the outcome variables, the mediators, while controlling for one another, and in turn, whether the mediators predict healthy eating behavior while controlling for one another and also controlling for the predictors. Okay. So let's look at that in action. Back to our example. Again, it's still running those initial analyses. Let's again go to the jAMM module. Let's specify a model in which once more we have behavior as the outcome. We've got our 2 mediators, opportunities and intentions. And now also 2 predictors, attitude and norm, entered as covariates, continuous predictors. There's the model summarized in schematic terms, attitude predicting behavior, both directly and indirectly via opportunities and intention, and likewise for norm perceptions. Once more, we've got our default output here, and I'm going to ask for, once more, 5,000 bootstrap resamples, bias corrected as a basis for testing the indirect effects. So again, just to save time, I'm going to skip back to a version that's already been run. Okay, there's the model summarized that we've just tested. And here are the outcomes of those tests using the bias-corrected bootstrapping estimate for the standard errors and confidence intervals. So I'm just going to skip directly to the indirect effects here. So again, as I stressed, we have 4 separate indirect effects with 2 predictors and 2 mediators. So let's look at the indirect effects from attitude, first of all. Attitude via intention to behavior is significant. The confidence interval does not contain 0, 0.22 and 0.89, but the effect from attitude, or the path from attitude to behavior via opportunities, is not significant. The lower limit, minus 0.07, and the upper limit, 0.23, that does contain 0, so we would not regard it as significant. So what about indirect paths from norm perceptions? Well, the path from norm perceptions to behavior via intentions, the confidence interval, also does not contain 0, 0.03 and 0.49. So we would regard that as significant. The path from norm to behavior via opportunities, on the other hand, let's have a look at the confidence interval, minus 0.07 and 0.21. That does contain 0, so we would not regard it as significant. Okay, and again, here are the various A and B paths in that model, which I won't run through in this case. Okay, plus now 2 direct paths from each predictor, attitude and norm perceptions to behavior. Okay, so how would we summarize that? Let's just skip back to the slides. So again, in this model with now multiple predictors and multiple mediators, we could summarize the outcomes as follows: that the indirect path from attitudes to behavior via intentions was significant, but the indirect path via opportunities was not. Now that indirect path, that coefficient, if I just skip back to look at it, is positive. So what that shows is that an increase or higher attitudes are indirectly associated with more of the behavior, more healthy eating behavior, via higher intentions. Okay. So the coefficient for the indirect path is interpreted in the same way that you would any other coefficient. If it's positive, it means that higher values of the predictor are associated with higher values in the outcome, and a significant and negative coefficient indicates that higher values of the predictor are associated with lower values of the outcome variable. Okay. So one final thing here is that the bootstrapping approach to analysis, by its nature, involves each time generating a new set of 5,000 or however many. Now, I've used 5,000 as a sort of a default. That's sort of like the lowest number that you would expect now in a bootstrap test of, well, I guess, of anything. Okay, there's no reason you can't use 10,000, 15, or 20,000 bootstrap resamples. Okay, but what happens each time you run a bootstrap test of an indirect effect or of anything is that you're asking it to generate a new set of 5,000 or however many new bootstrap samples. Okay, so what that means is those 5,000 samples, the second time you run the analysis, will not necessarily be exactly the same as the bootstrapped samples from the first analysis. Okay, so what you will see is that each time you run, when you use these techniques, each time you run the same analysis, you will probably see very slight variations in the things that have been estimated from the bootstrapping, specifically the values of the standard error, the confidence interval upper and lower limits, and also the Z statistic. Okay, so I'm just going to show you that, hopefully by comparing the analyses that I had already run. Let's see the first one here. Okay, this is the simple mediation analysis. That's the table. And I'm also going to go to the one that I actually ran, which hopefully has now finished. Okay, so I'm just going to scroll up and try and find it. There we go. Yes, it has run. So let's compare those two. So remember, this is exactly the same model, tested in exactly the same way. Okay, so this is the one that I summarized in the lecture slides. So let's have a look just at the indirect effect. Okay, coefficient 0.66. Now the coefficients will always be the same from analysis to analysis. Okay, those should not change. But what will change are the bootstrapped bits, the bootstrapped estimates. Now, as I said, the main thing that's bootstrapped here is the standard error. So the standard error of the indirect effect is slightly different. Okay, in this version of the analysis, it's 0.15, and in this version, it's 0.145. In turn, the confidence interval limits are ever so slightly different. So the upper limit is actually the same, but the lower limit here, 0.39, the lower limit here, 0.386. So ever so slightly different. And the same is true of the other estimates in the model. The coefficients are always exactly the same, but the standard errors, okay, will be ever so slightly different from analysis to analysis, from each time you run the same analysis. Okay, so I just want to flag that, mainly to say that if you, for example, try to replicate these analyses with the data and you find that the values are ever so slightly off what I found here, that is actually absolutely fine. Okay, that is just because each time you run the analysis, you're generating a new set of bootstrap samples, however many thousand that you specify. All right, and it will generally lead you to exactly the same conclusion. Okay, so fundamentally, nothing changes in the inferences that we make from these data. All right, so just something I wanted to emphasize about bootstrapping as an approach and the quirks and slight variation that you will see each time you run the same test. Okay, that's it for this session on mediation and indirect effects. Next time round, we'll turn our attention to moderation analyses when we have continuous predictors. All right, thanks for watching and see you then.